I bought this house last fall and I set up shop here in the basement. As you can see, I have an office right off the side here, and I'm dealing with two big problems down here. One is that it's not conditioned. The other problem is that the air down here is pretty stale. What we have here is something unique I've never seen on the market before. This is a mini split that has an integrated energy recovery ventilation system, or an ERV. And if you don't know what that is, this is a fresh air makeup system that actually attaches to the mini split header. This is our ductwork where the fresh air comes in, stale air goes out. And this isn't just a fan, this is an actual heat exchanger. It tempers the air coming in so you're not pulling in really hot, really cold air from outside. Once we get this thing on the wall, I'm going to be really interested in testing this and taking some measurements to see how effective this really is. So here's the game plan. Behind this wall, I have a 113-year-old foundation that's 3 layers deep of brick and some concrete. Not about to start drilling through it. So I've decided to sacrifice this window because I don't get much daylight through it. The only thing for me to look at is the bumper of my pickup truck, and it's not even really a window. It's plexiglass. And I got a ton of cold air coming in there through the wintertime. We're going to frame this off. I'm going to close it off. We're going to use this as our exit point. We're then going to finish off this wall nice and give it a feel that matches our unit. All right, let's saw mini split. The mini split videos you see out there, a lot of them are going to tell you to start looking for a stud to mount your bracket. That's not what we're doing today. We have a little bit extra to take care of here, which is the ERV. So what I want to do is I want to make sure I have enough room, not just for my drain and my line set, but also the tubing for my ERV. We have to connect these tubes and go through the wall. So I want to make sure I don't have a stud in that area. So I have about 10 inches here I need to make sure I don't have a stud in the wall that's going to get in my way of any of this. And so what I'm going to do now is I'm going to locate 2 studs in the wall where I patched up my window, and we're going to mark that off. Now, the first thing you want to do before you pick a potential spot where you're going to be going through the wall is you want to look down on the wall. What we're looking for are electrical outlets. These are going to tell you 2 things. Number one, it's going to tell you where a stud is because those electrical boxes nailed to one. It's also going to tell you where there could potentially be a wire in the wall. Now, I already know where I am here because I know exactly where I'm going through. I know there's no wires there. I know there's nothing on the other side and the outside of the house as well, and that's something else you'd like to check. Now, I already know where my studs are in the wall because I framed it out myself when I closed off this window. So my stud's right here, and I have another one right around here, and that gives me the 10 inches that I need to go through with all this stuff. So what I'm going to do is I'm going to measure 6 inches from the ceiling, from the top, because that is the clearance we need from the top of the unit for proper airflow through the header. So I'm going to go 6 inches, and I'm going to go lower than that and just mark off right here near the stud. And that mark will be covered when I put the unit up. Now from this mark, I'm going to measure 10 inches over to my left. That gives me the room I need to go through. And that puts me right there. Now what I'm going to do is I'm going to measure 6 inches from the ceiling, and I'm going to go just past that, about 6¼ inches. I'm going to mark that off right there, and that's going to be the top of my unit. What I'm doing now is grabbing a measurement on how tall the unit is, and I got 11.5. From this mark I made 6¼ inches off the ceiling, I'm going to go 11.5 down. All right. And that's the bottom of my unit right there. That's where it's going to be. So top of the unit here, bottom of the unit here, 10 inches I need to go through the wall. All right, so here we have our 2 marks. That's the 10 inches. Our header is going to be sitting this way. The ERV is going to be right here. So I'm going to come to the edge here. I'm going to put a long level. I'm going to make sure it lines up with that line, level straight. And I'm going to come down to the bottom mark that I made. That's the bottom of my unit, and I'm going to make a little dot there to make sure that when I measure over that 6 3/8, I'm not going too far either way. Right there, and that's going to be the edge of my hole saw right there. I'm now going to measure 8 3/8 from the top of the unit. That's my line right here. So I'm going to go 8 3/8. That puts me right here. So here's the edge of my saw, here's the top of my saw. Now I could just line these 2 up, and I could trace out exactly where my hole is going to go. Right there. So next thing we're going to do is I'm going to take a long drill bit like this and drill a hole straight through to the outside. Now, one thing we have to keep in mind is we need a little bit of a pitch for our drain line so that water can drain properly. Now, a lot of guys might tell you when you drill the hole, pitch it upwards like this so the bit goes down. But I don't do that anymore unless I'm drilling through some really thick wood. And the reason why is because if you look at this pitch, if you don't know how wide that wall is, if you have a wide wall, you're going to end up with a hole up here and a hole down here. And that's going to make it really hard to run your line set through. And we don't need that much pitch for water to drain. So what I do instead is I hold it very, very straight, and then I just drill straight out. And then what I'll do on the outside is that hole on the outside, I will drill about 1/2 inch to 1 inch below, and then I'll cut that hole. And that will give me all the pitch I need. So here's our hole on the outside right here in this shadow where it's a little hard to see. So what I'm going to do is I'm going to take the tip of my bit and I'm going to place it about 1/2 inch to 1 inch below that hole, and then I'll just cut my new hole. Now I'm ready to mount the bracket on the wall. But before I take the bracket off, I need a couple of measurements so I know exactly where it's going. Now I measured center on this bracket, and that puts me at that hole right there as center. So the measurement I need is how high on the wall do I need to mount this. Now we're going 6 1/4 from the ceiling to the top of the unit. So now all I need is a measurement from the top of the unit to that hole, and that gives me 2 inches. So we're going to go 8 1/4 inches down from the ceiling. The next measurement I need is where, from left to right, do I need to mount it. So I'm going to measure from the edge of my ERV to that center hole, and that gives me 21 inches even. Now I'm going to mark the center hole for my bracket. We're going to have 21 inches from the end of the ERV, which we already marked on the wall earlier. So I'm going to go over 21 inches. I'm now going to go 8 1/4 from the ceiling on that spot. And that puts me right there. Now I'm going to take one screw, line it up with that mark. Then I'm going to go ahead and throw a screw in there. Now I'm not going to tighten it up. I'm going to leave it a little loose so I can have some play here. And this is I'm going to level it off before I tighten it down. So I'm just going to take a little speed level, put it on there, make sure it's level. And I'm going to throw another screw pretty much anywhere else. Now what you want to do now is if you're going through drywall, you want to find your studs. So you use a stud finder or whatever, and you mark off all your holes, you mark off where the studs are, and anywhere you have a stud, you want to sink some drywall screws in there. Now if you don't have studs anywhere along this bracket to screw into, that's okay. It's not the end of the world. These things aren't that heavy. But if you're going to use drywall anchors, use a lot of them. Don't go flimsy on 10, 15 minimum. We want this thing to stay on the wall. Now, if you are going to use drywall anchors, I strongly suggest you use these. And there's a couple of benefits to these. Number one, you could see by the design, it actually grips into the drywall as you put it in. The second advantage of it is that you only need one tool for this. When you use regular drywall anchors, you have to pre-drill a hole, then you have to stick the anchor in, hammer it in, then you got to get the drill to put the screw in. So you need like 3 different tools to do it. But with these, they go right on the end of the Phillips bit, you drill it right into the wall, and then you just drill your screw right in with it, and that's it. All you need is one tool. So it's win-win. More support, faster to put in. Now once you got everything marked out, you can go ahead, take the bracket back off the wall, sink in your drywall anchors, and then go ahead and remount it and get all the screws in. I don't have to worry about that because I have all wood behind here, so I'm just going to go ahead and throw all my screws in. Then we're going to put this on the wall real quick to see how it looks so far. All right, so this thing's looking pretty good. So let's take it back off and on to the next step. Now the next thing we have to do is hook up the communication wire between the header and the ERV, or fresh air makeup. Now they give you 2 wires to do this, a short one and a long one. The short one is if you're going to be putting the ERV on the right. The long one is for on the left, which is what we're doing today. Now on the back side of the unit, there's this plug here. It's the larger one. And you're going to have a little blue clip and a cover that's on there. You just pop this blue clip off, take off the cover, and then we're going to take this end of the long communication wire. We're just going to go ahead and plug it right in there. And there you go. So what we're going to do next, we're going to hook up our communication wire. This is the signal between the header inside and the outdoor unit. So what we're going to do is we're going to run it through the back of the unit into the electrical panel up front. So I have this on the table. I opened up the front panel, and there is a cover over the electric box. It's just one screw holding it in. You just take it out. Now on the back side here, there's this hole. We're going to go right through that and fish it into the front. There's a little bracket here with a screw holding it in. That's to hold the wire down, so we're going to remove that. And now we're going to go ahead and we're going to make all our connections. So the green is for ground. This is our ground symbol all the way to the left, so we're going to put that right in there. Now a brown wire here, that's going to go on terminal 3. So we'll connect that. Our black wire here, that will go on terminal 2. And our blue one will be going on the neutral, or terminal 1. We can now put our clip back in place. Now we're all done there, we can go ahead and put our electrical cover back on. Now I'm going to take my communication wire, I'm going to run it outside. Every mini split needs a minimum length line set between the indoor unit and the outdoor unit, and this facade needs at least 10 feet. Now, instead of unraveling this whole thing, trying to feed it through and then raveling it back up again, I'm just going to unravel about 2 or 3 feet to get through to the inside. We're going to feed it outside in. We're going to make our connection, and we're just going to leave the rest raveled up. Because once you stretch these things out, they're very difficult to roll back up again without kinking them. All right, so our line sets through the wall into the room, and because I'm going out through the wall on the left side and my copper's on the right, I'm going to have to put a bend in this and make the connection here and then lift it up and put it in. So my hole is going to be here on the wall, and I need roughly 14 inches from this flare nut down to where the bend is going to be. Okay, so now I'm ready to make my flare connection. So I'm going to loosen this cap up here, and you can hear that air coming out. That's a good sign, because that pressure is telling you there's no leaks in this evaporator coil. Now I'm going to use a little paste here called True Blue. It's going to help get a better seal on this, and I'm just going to put it right on the edge here. Then I'm going to go ahead and make my connection and thread it all the way down. Now a lot of people, they'll use just 2 regular wrenches to tighten this, but you do want to use a torque wrench because we're dealing with soft copper here, and if you over tighten it, you can crush down the copper wall, and that'll compromise the fitting itself. They'll blow right off if you over tighten them. So the manual will tell you how many foot-pounds. So I adjusted my torque wrench, and I'm going to go ahead and tighten it up. There we go. Now I'm going to do the same thing on the smaller line. I took the black cap off. At that point there won't be any pressure because you already let it out. Now this smaller line, it's a different torque setting, so they're both in the manual for the torque setting for each line. So I readjusted, and I'm going to go ahead and do the same thing here. There we go. Now you want to make sure your copper's all covered with insulation because you don't want any sweating. You don't want any of that water to drip in your wall or behind your unit. I'm now going to take my communication wire and the wire for our ERV. And I'm going to go ahead and I'm going to tie it to the line set so it's all nice together in a bundle. We can move our drain line out of the way. What I'm going to do now is I'm going to zip tie the drain hose to the line set, and then we're going to feed it back through. Now, when you do this, you want to make sure your hose is underneath the line set. You don't want it to the side or on top. You want it on the bottom. Otherwise, it won't drain properly. The one last thing we're going to do before we feed it back onto the wall is we're just going to snip this little piece off right here of this knockout. And this is for our communication wire for our ERV, which slides right in there. All right, so that's all done. Let's get our ERV in now. All right, so this is going to be pretty simple, straightforward. We have a template here that came with the unit. I knocked it out, and we're just going to set the template there right up along the side of our header. And then we're just going to trace out our hole. This is going to be a 4.5-inch hole saw. And then we're going to place our 2 dots for our bracket screws. And now I'm going to cut out the hole. After I cut my hole, I just took my long pilot bit and I poked outside so I know where I am out there. Now, unlike our line set and our drain line, we don't really have to worry about pitch here. It's just airflow. So now I'm going to go outside, cut those holes. Now, the same template I used inside, I'm using outside. And I put the big knockout back in, taped it on, and knocked out the 2 smaller holes. So what I'm going to do now is I'm just going to trace it out. And those are going to be 2 holes I drill. Now I'm going to use a 2-inch hole saw for each one of these. All right, what I'm doing now is we're going to send in the air tubes. These tubes, they have 2 sides to them. There's a recessed side and a protruding side. We're going to send in that recessed side. So now we're just going to go ahead, put our bracket on the wall lined up with those 2 dots we made and screw it in. Now our ERV is going to sit on the wall like this. So on the side, we're going to take that little knockout just like we did on the header for the communication wire. And then on the back, we're going to remove this electrical cover to make our connections for the communication wire. All right, so I got my little knockout. I took my back cover off, and now we're going to take the communication wire from the header. And this little black piece right there, there's a little slot. We're going to stuff it right in there. Okay. And these connections, they're self-explanatory. They only fit one way together, so you can't screw it up. Now we're going to take our wire, we're going to tuck it in back down here so we can get our cover plate back on. So here we have 2 hose connectors. One part snaps on the back of the ERV. The other screws into the air hose. So I'm going to go ahead and I'm going to screw these in. So now I'm going to lift the ERV up and I'm going to snap those hoses into the line, the back of the ERV. I'm going to make sure my communication wire's tucked in, and then we're going to lift it up onto the bracket. And there we go. All right, so all we have left to do now is I cut these hoses off. I used a metal blade and a Sawzall for a nice clean cut. And we're just going to put our rain cover on here. So we just slide it right on. And that's it, we're done. Now we can set our condensing unit. So as you can see, I did something a little bit different here by building this stand. And there's a very, very good reason behind this. Earlier in the video, I mentioned these units need a minimum of 10 feet of line set. And because my indoor and outdoor units are on opposite sides of the same wall, I have to leave that line set coiled up. Now, a lot of guys, they'll just leave it coiled up sitting right behind the unit, but I'm not going to do that because, number one, it doesn't really look that good, but number two, there's actually a performance reason behind it. When you leave a coiled up line set vertical, you can create potential oil traps at the bottom of that coil. Now, when this unit's running at full capacity, that's not a big deal. It'll just blow right through it. But this is a 24.5 SEER unit. This is high efficiency. And in order to get that high efficiency, these inverter motors draw down very low powered and they run at very low capacities, and that's where all the energy savings is. It's in those moments that the system can have a hard time pushing that oil through those traps, and you end up with issues with the system performance, or at the very least, a big reduction in your energy savings. So I built this stand so that I can lay it down horizontally to avoid those traps and tuck it underneath so it's out of sight. Now I'm going to go ahead and I'm going to hook up my line set here the same way I did it inside at the indoor coil. All right, so what I'm going to do here is a quick pressurizing with nitrogen just to check for any leaks. So what I'm going to do is I have my yellow hose from my manifolds hooked up to the nitrogen tank, and I have my blue hose from my manifolds hooked up to the large suction line on the unit. Now you need a 5/16 adapter to connect to these. These are 1/4 inch hose connections, and you need that adapter to connect to pretty much any mini split out there. So what I'm going to do is I'm going to slowly open the valve that lets nitrogen into my manifold. That would be the yellow one. And now I'm going to crack open just a little bit the blue valve to pressurize the line set. Now I'm not going to go crazy on this. I'm only going to add 50 or 75 pounds. And I'm just going to let it sit there for a second just to make sure I don't have any major leaks. There's no point in dumping a whole bunch of nitrogen in if you got to let it out to fix something. All right, so that looks good. I'm going to bring it up a little higher. We're going to go maybe, let's say 200. And I'm going to do the same thing. I'll let it sit for just a minute to see if it drops off. So as I'm going higher and higher, I'm checking for smaller and smaller leaks without wasting a lot of nitrogen. All right, so that looks good. Now I'm going to bring it up pretty much to like 350. All right, just a hair over 325, that's good enough for me. So we're going to leave that there for a few minutes and make sure it doesn't drop off. Now, sometimes these systems, they have adjustable valves in them that adjust the refrigerant flow. So it might take a few minutes for the pressures to equalize across those valves. So I always wait about 5 minutes before I mark off where my pressure is, just to accommodate those equalization pressures. Now, a lot of people will skip over this whole step. It is what it is. I've done it a few times myself in the past and gotten away with it just fine. But there's a huge potential cost savings benefit to doing this. The whole reason why we do this pressure test with nitrogen is because a vacuum test is not for leak checking. It's to remove all the non-condensables and moisture from the line set. And if you have a leak, all you're doing is pulling more in. You also don't want to check for leaks after you've already opened up the ports and let refrigerant into the system. Because if you do have a leak, your tendency is going to want to take a pair of wrenches and try to tighten it up. And if you over tighten these flares, they're going to pop on you, and then you're going to lose all your refrigerant. What this test does is ensures me that my system most likely has a very good seal on it, so that when I pull a vacuum, I'm actually taking all the moisture out, not drawing any more in. And if my vacuum holds, by the time I let refrigerant in, I'm not taking any of those risks. So let's check our pressure. Let's see if it's holding. All right, so there we have it, 325 on the nose. It hasn't budged. So now we're ready for a vacuum. Now, the setup for the vacuum is really simple. It's straightforward. All you need is one hose from the vacuum pump itself to your manifold gauges. So that's usually going to be the middle hose, the yellow one. And then you just need a hose from your gauges to the unit. Now, the only thing I did different was I used one of the extra hoses that I'm not using in this process to hook up what's called a micron gauge. A micron gauge allows you to see very small incremental changes that will never show up on your gauges. This can pretty much ensure that if you have a very, very small leak, you'll find it with this, where you may never see that on your gauges. You start the system up, Everything runs fine for several weeks or maybe even a couple of months, and then all of a sudden it's not cooling anymore. So this helps us find those little micro leaks that avoid that situation. Now this measures in microns. What I want to do is I want to get down below 500 microns. That's the absolute minimum. So before you start, you just want to make sure your oil level on the pump itself is above the minimum level. You want to make sure you do have clean oil, because dirty oil will affect the performance of the vacuum. And you always want to make sure any hoses you're not using, that valve is closed. So I'm closing this one here. This red hose isn't hooked up. This yellow hose here is to my micron gauge, so I want to make sure that's open. This other yellow hose is for my vacuum pump. I also want to make sure that is open. I also want to make sure my blue hose going to my unit is also open. So now all I got to do is turn the vacuum pump on. And I'm just going to let it run until this gets below 500 microns, however long that takes. Now, if you don't have a micron gauge, I very strongly suggest you just let this vacuum run for like an hour or two. There's no such thing as overkill here. It's not unusual for me to see that it takes much longer than just 10 or 15 minutes for us to reach that 500 micron we're really looking for. So letting it run for an hour or two is an insurance policy to make sure you actually got all that moisture and non-condensable gases out of the system. If you only do 10 or 15 minutes, you could be leaving a lot in there. Now, the whole point, by the way, of getting all that moisture out is because that moisture will mix with the oil that's in the system and it'll start breaking down. And that's what's protecting our compressor inside. It can also start creating acids, eat away at the windings, and you end up destroying the compressor. So getting all that out is really important. Let her run. All right, so now I'm down below that 500. I'm at 460. I could let it run longer, but that's good enough. So what I'm going to do now is called a vacuum decay or a vacuum rise test. So what I'm going to do now is I'm going to shut the vacuum off. I'm going to isolate the vacuum pump itself, and I'm going to leave everything else open. So now what I'm going to do is I'm going to wait about 10 minutes and I'm going to keep an eye on it and see how quickly this vacuum breaks. Now, if it comes up very, very quickly, that's an indication of a leak. If it comes up slowly and then starts to slow down and level off, that's what I'm looking for. Now, I'd like to see this stay below 1,000 microns. The lower, the better. Now, if you're doing this without a micron gauge, I very strongly suggest to leave the vacuum there for as long as you can, just like the vacuum pump. Leave it there for a couple hours, because if you have a very small leak, it's going to take that amount of time to see that change on your pressure gauges. Now, this is the new A2L R32 refrigerant in this system, which is actually a good thing. The 454B is in short supply, and it's going for about $1,500 a jug. So this is your last chance to check for leaks before we let refrigerant into the system. So if you have the time, definitely take advantage of it. All right, so all we got left here is electrical. I already ran power out to a disconnect box a week before this thing even showed up, just to get that out of the way. But basically what I'm doing here is that this is a 120 volt unit. So we only need a single pole breaker with one hot leg and a neutral to power this. Now, whenever you're trying to figure out what size breaker, what size wire with these units, you want to look at the data plate on the outdoor unit. That's going to tell you a minimum and a maximum amperage draw. So this is going to tell you how much amperage this unit is going to draw when it's working its hardest. So this unit pulls just over 15 amps. I'm not going to put a 15 amp breaker in because this thing might trip on some really hot days that way. So we're going to put a 20 amp in. And when we match wire with a breaker, what we're really looking at are heat ratings. How much resistance that wire and heat that's generated from that resistance the wire can withstand safely before we start having issues. Now with a 20 amp breaker, I'm going to be using 12 gauge wire. The great thing about SAW is that they actually put in their manual, based on the model number, what size breaker and gauge wire you should be using. Now when you look inside this block here, you can see 4 terminals. The 2 middle terminals are your line terminals. Line is the voltage coming from your electrical panel inside the house. The 2 outer lines are your load. That's your condensing unit. Whenever you're hooking up high voltage wires, you always want to do it in this procedure. Ground first, then neutral, then your hot leg. And the reason for doing this is because crazy things do tend to happen. Even if you know the other end isn't even connected and just dangling in midair, You might have a situation where you have a helper on site. He thinks he's going to surprise you and do the work for you. And if you ever touch that black wire, because that's the one you're hooking up first, you become the ground. You become the neutral. You become the only option for that power to complete the circuit. But if you hook up your ground and your neutral first, electricity has better options and it can save you. Okay, so the next thing we do is we're going to hook up our communication wire from the indoor unit as well as the whip from our disconnect. So I took this cover off right here, as you can see, and I knocked out the two knockouts and I put these Romex clamps on there. One's going to be for communication, one's going to be from power from disconnect. Now I'm going to go ahead and I'm going to run those through. So what we're going to do now is we're going to connect our high voltage first because these are the two lower terminals and we don't want to get in our own way by hooking these top terminals up first. So I'm going to go ahead and I'm going to hook up the ground to the ground screw. I'm now going to hook up the white wire to terminal 1, which is our neutral. And then we can hook up the black, which is our line voltage, 120 volts. Now this is essentially the same exact procedure. We have a ground wire. We're going to hook that first to the other ground screw terminal. Then we have our white wire there, same thing, and number 1 terminal. Then we have our black wire. That's going to go on number 2 terminal. And this is the power that's going to power the indoor unit. So the indoor unit runs on 120 volts, and this is where it's going to take its power from. Now this brown wire here, that is our actual communication wire. This is a low voltage DC signal between the unit and the indoor unit so they can cooperate with one another based on changing loads. So that's going to go on our last terminal, terminal 3. Okay, so what I'm going to do now is I'm going to slide this bracket piece back up. I'm going to throw this on top and I'm going to throw my screw in that holds it onto this plate. So at the other end of the whip, I ran it into the box with my clamp connector, secured it, and we have our ground wire, our neutral wire, and our hot wire. Also strapped everything up on the line set together so nothing's flimsy and flying around. So now we're going to open up our service ports, and even though I have a service wrench like this, I'm going to actually start using with an Allen key. And the reason why is because these manufacturers, they tighten these things down sometimes. Sometimes that service wrench might strip, and then that's not what you want. So we're going to use an Allen key just to crack it, and we're going to start with our liquid line. Now the reason why we're starting with our liquid line is because the liquid refrigerant that's in this unit is on the outlet side of the compressor. And so if we open the suction line first, it's going to create this big pressure differential, and the compressor is going to want to suck that liquid right into the compressor, and that's not what we want. So we're just going to crack the liquid line just a little bit. Nothing crazy, just crack it. Now once it kind of equalizes, we're going to go ahead and we can use the service wrench to open it up all the way, or you just keep going with the Allen wrench. Now, once it stops spinning, you don't want to keep going and crank it. Just let it stop where it stops. You don't need to backseat it all the way real tight. We're now going to go ahead and open up the suction line. And you don't really need to go in slow on this. Then you can just go ahead and use the ratchet and open it up quickly. All right, so that's it. We're all done. Now is the part we've been waiting for. Let's flip on the breaker. We'll put that disconnect in and we'll get this thing up and running. Okay, so I turned the breaker on, the disconnect is in, powered everything up, and we have our little power symbol here. That is a good sign. So before I turn this thing on, I'm just going to throw the HEPA filter into the ERV. To do that, there's a little panel right on the side here. You just take that right off, and we're going to slide the filter in. Throw the panel back on, and we're ready to go. All right, so let's turn on the power and let's start off in cooling mode. Now Now, when you first start these things up, they kind of go through their little thing to kind of get organized, and then it'll start up. So it might take a minute or two. That's not unusual at all. It's pretty normal. All right, so she's kicking out some cool air right now, which is cool. And that was such a dad joke, man. But all right, so I don't care about that right now. I want to get this ERV going. Now, I could not figure out how to turn this thing on. It wasn't in the manual. I couldn't find it anywhere online. It drove me nuts for probably at least a half an hour until I looked in the back of the remote, and there it was. So what you got to do is you have to press mode and I feel simultaneously. And there we go. The light came on, and now we got air flowing. So first thing I'm going to do is I'm going to see what kind of a temperature differential we got here. I already took the ambient temperature outside. It's currently 85 degrees. I want to see what the temperature of my air coming in from outside is. All right, so the air outside is 85 degrees. The air coming out of the ERV is 70 degrees. So that's quite impressive. Now let's see what the room temperature is, of course. On the return side and on the top side of this header. And it's also 70 degrees. So we're maintaining room temperature with the air coming out of this thing, even though it's pulling in air from outside. That's pretty awesome. I was expecting a little less than that. Now I'm actually looking forward to those really hot days or those really cold days to check this again and see what I get at that point. But if this thing is putting out close to room temperature while drawing in air from outside, that's not going to affect the efficiency of this unit too much. So it might not be much of an issue as far as longer cycle times or more frequent cycle times. So the next thing I did was decided to take some decibel readings with this unit on full blast and measuring right in the direct path of the airflow. Now I took a baseline in the room, it was 28 decibels, and when I held it up here with the system running full blast, it was kind of averaging about 60 decibels. So we had about a 30 decibel increase, which is not a lot. I looked up what other sounds are 30 decibels, and on that list was the interior of a library and a whisper from 3 feet away. Now I did the same with the outdoor unit. I took a baseline outside that was about 32 decibels, and as I walked up to the unit, I got the same thing. Maybe about 65 decibels is where it peaked. And so we're still talking about 35 decibel increase there. My unit's right on the other side of the fence. If I stood on that side of the fence, I couldn't hear it. So I took some temperature readings just to see what our output is in heating and cooling mode. In heating mode, we're putting out 111 degrees, which is pretty good. Cooling mode, we got down to 55, and that's on an 85-degree day. Now I'm going to keep doing tests on this thing. I want to see how it performs in more extreme situations, so I'll eventually come back around to this. If you have any questions about the unit at all, leave a comment and I will try to get back to you. I do get a lot of comments, but I always try to keep up. Now, if you do decide to get one of these for yourself, I do have a discount link below, 20% off. Just use Jersey Mike HVAC as a discount code. And if you do decide that one, take advantage of it. Otherwise, whatever. Me, I'm going to go cook a cheeseburger because I'm freaking exhausted. And I'm going to go eat it in my brand new air conditioning with fresh air.